video 2 in SynAnalyzer, and I forgot to mention something really important at the start of the other video, so I'm going to take a minute just to highlight it really right now. The computer that you're using already has all of the code saved locally as a local repository, and I did that by cloning it from GitHub. So you don't need to worry about this right now, but in the future, if there is a change to the code, you're going to see it in GitHub, and then you're going to want to actually fetch those changes from the main repository. And so your computer also has GitHub Desktop on it. You just need to sign into GitHub. Once you've signed into GitHub and if your repository was already cloned from GitHub, you should be able to see it there. So we can talk more about that at another time, but it just for anyone watching this video, because I didn't give the full backstory on where the code actually came from, you can access it here. So if you go, just search GitHub Engineering Joy, it pops up right there. And then SynAnalyzer is at the top right now, but if it's not at the top, you can go to repository, SynAnalyzer, and then you can do all of the usual GitHub things from there. You can fork it, clone it, whatever you want. You can also just open up the files here, and you can see the notebooks. And then for things like the ImageJ code, just thinking, if you run into an issue later on, then, so this is what the ImageJ code looks like. You can also just copy paste from here. All right, so the next step, so where we are right now is that we just converted all of those Amara stats files into CSV files that ImageJ can work with. So let me show you what those look like. So for every surface that you reconstructed, either postsynaptic or presynaptic, here, these are all presynaptic reconstructions. Every surface has an ID, and that's assigned by Amaris. And what that conversion notebook did was it took the positions, the XYZ position that was in the Amaris stats files, and just added it here. And then it also gets some other fun information. It gets the volume. It also gets the intensity within that volume in each of the different fluorescent channels, right? So we have 4 different channels, and so that's what the intensity is. And you can probably guess which of these. This is probably the CTBP2 channel. I'd have to remember, but and then these XYZ positions in terms of voxels, those values were calculated using the conversion factor that I highlighted at the beginning of the video. So when I said you just need to make sure, like, what's the voxel size of your image and make sure that the value there matches what the value is of the actual image. That's what I was talking about, because long story short, this can't be done in ImageJ. The math isn't accurate when you do it in ImageJ, so I did it in Python using these XYZ positions and the conversion factor that I entered in the notebook. All right, so we have one of these for every image that we want to analyze. I'm not going to save it. Don't change those files. They should be left exactly as they are. We're going to make a different version of them in ImageJ. All right, so I'm going to go to ImageJ or Fiji, whatever you have. You probably want to make sure that you have Fiji. The computer you're using has Fiji for sure. All right, and then I'm going to open up my code. I'm going to do that later. I don't need to update things. So open. I'm going to navigate to my code. This is a different repository. Go Documents. No, I lied. On your computer, it's in Documents. On my computer, it's here. All right, but the file that I'm looking for is 2.0 SynAnalyzer Analyze XYZs.ijm, ImageJ macro, IJM. I'm going to open that. I shouldn't need to touch anything because I ran this recently and everything should be good. But the thing that you definitely need to check, and I'm pretty sure your computer's already set up like this, Oh, yeah, I do actually need to change something because I'm using a different batch right now. So see, the last time that I ran this, so this is the default batch path, and this part's really important. The code needs to know where to look for files, and this is the path, this is how it looks for those files. And the very last part of this path is it needs to be the folder name here. So I'm just going to get this folder name, and then I'm going to put it here. Okay, so now it should work. Fingers crossed. Hold on to your butts, and we're going to run. All right, so when we hit run, the first thing that happens is this little window pops up, and it's going to give you some instructions. It says this macro is going to open your Z stack of choice and create a thumbnail array of regions around specific XYZ coordinates based on the accompanying CSV files. That's what we opened in Excel, and that's what we converted from the MR stats files. All right, and then it enters, by default, it enters the batch path that is here in the code. So you shouldn't need to change this. It should just be good. Hit OK. All right, and then it's going to ask you, choose your analysis mode. And you saw how there was kind of a flash of a screen and you didn't see it right away. What the code was doing in the background was setting up all of these new these folders. So those folders didn't exist before. Most of them are empty because they haven't been used yet. But one of them, this is very important. This is the batch master. This file is going to be one of the most important files that you want to make sure that you back up. So the batch master has every single image, and it's gonna store all of the data associated with that image. So things like it's like you'll see it populate later on. But like, the number of orphans, the number of synapses, blah, 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 blah. All right, so don't save it. Don't change it outside of Batchmaster if you can avoid, outside of SynAnalyzer. Okay, so now we're going to choose our analysis mode. If you want the code to just iterate through every single available image, you want to run in batch mode. But more likely what you want to do is actually analyze specific images because you're probably not going to do 40 images in one setting. So what I would recommend is to open up your imaging metadata sheet. Mine looks different than yours, and we'll go over that later. But the reason I'm pointing this out is because if you're going to just analyze 32 kilohertz images, you want to select those, right? Because your CZI folder, your raw images folder, it has every single image that you took in it, and you probably don't want to analyze those all at once. So you want to use this imaging metadata sheet to say, okay, only analyze the 32 kilohertz, what's the name of that file, and just go through them. So we're going to run in specific image mode. We're going to say okay, and then see the drop-down menu. It has all of the images, and I don't want to do all of them. So we're going to do just 38231. So that's 38231, if I remembered it right, but either way, it doesn't matter because it's just a demo. All right, and then I'm going to click OK. And it's going to give me some instructions. You can see that the batch master is now open here. So it's important that you keep batch master closed. The file should be closed outside of ImageJ. Don't have it open in Excel when you're running this code. But so this is what it looks like. And you can see, oh yeah, that's the file that we're analyzing right now. And it checked the XYZ data sets, and there's only the presynaptic data. So that's all we can do with this file. We're going to click OK. And now bioformats is going to open. And on that previous screen, it was giving me directions that I just ignored of how I should set up the bioformats importer. So just go back and look at that little note and just make sure that all of these things are correct. And I'm pretty sure that they are because it should just be default, is that you don't want to split channels, you don't want to auto scale, you want this to be a hyperstack, and then click OK. Ignore these errors because that's just related to how our Zeiss opens files. It'll take a second for the file to open, so just be patient with it, and then you're going to get another instruction that's going to say you want to adjust the brightness contrast in each of these channels. So when you do this brightness contrast adjustment, the whole purpose is to get the dynamic range of the display set to what looks best on your computer, because those settings are going to be used for all of the max projections later on. So you have to do this channel by channel, and it has to be manual. So we're going to say OK, and then, oh, I didn't actually make the adjustment. Sorry, I got so distracted. Okay, so what I can just do is hit cancel, close this window, and restart. So it's not running right now. Restarting it. It's fine. Specific image. Okay, so now because it's actually, that image was already initialized, now it's giving me a different window, and it's saying that, wait, sorry, did I just do that wrong? Kill that. Specific image, 2, 3, 1. See, I missed this window because I was rushing. So the image had been previously initialized, but I didn't complete the initialization. So I do actually need to repeat that process. So click yes. Okay, now I'm going to go back through. Okay, and so when Bioformats opens, default settings. So no boxes checked, do not split channels, do not auto scale. All right, no boxes checked, default settings, do not auto scale, do not split channels. Now I'm going to adjust the brightness contrast when they open. All right, so wait to click OK. It's like I should follow my own instructions. So what I'm going to do is go through each of the channels. So this is my Homer 1, and you can see how my postsynaptic marker looks so dim. So I'm going to adjust the brightness contrast. When you do this, you're going to make one adjustment for the entire Z-stack. So you want to make sure that you're on a slice where you can see the features of interest. I can see the puncta there. They're just really dim. And now I'm going to draw that up. Okay, and it's not great. It's not my favorite because what happens is it's the way that Auto ImageJ adjusts it. So you might have to play with this, but I'm just going to leave it like this right now. Click apply. You can also try doing a background subtraction. You might need to play with just a couple of images just to make sure you like how it's doing things. And yeah, do that to the entire stack. Okay, and then I have to go through and do this again. Okay, this is my hair cell marker, and it's so dim. So I'm going to do it again, right? You can see how bright it is now. Apply to everything, yes. Okay, and now here's my Calp 2. So my Calp 2. And here's my CTDP2. All right, so now I went through all the channels. Now I want to hit OK. And this is asking you which Z slices to include. For most purposes, you're going to include all of them. This would only be if there's if you accidentally made the Z stack so large that you included the mesenchyme and you want to exclude that from the max projection. So just leave the default settings and just click OK. So then it does all this crazy stuff, and then it asks you, do these XYZ points match the image? And so what you're hoping for here is that you could actually see the synapses, and then that there's a little dot on top of each of them. And these should be aligned with each other because those synapses are where your XYZ data came from. And the dots are the code's interpretation of those XYZ data points. So you can see that these hair cells were not included in my reconstructions, which is fine. It's great. There's no dots over them. So it looks good. Click yes. Okay. Then it wants to generate the thumbnails. So it gives you these status updates in case you have to go back and redo something. So it can tell you whether or not this has already been done before. TBD means that this has not been done yet. So yeah, we're going to proceed with thumbnail generation, and this is going to take a minute. So normally you would draw a huge box that covers the entire image because you want to analyze all the available synapses. For the purposes of this video, because we don't want to sit here for 5 minutes, I'm only going to do like one hair cell's worth, right? So let's just roughly put it right there, okay? And then I'm going to hit OK. And then it's going to ask me, do you really want to do this? Yes. And which channels do you want to include? You shouldn't need to change this because I'm pretty sure that I set this up to work for the channels that we always use. But just in case, this is the CTBP2 channel, and then this is the Homer 1 channel. And then click OK. And then it's going to do its crazy thing. So you have to just sit back and let it do that. Okay, it did it. And it was relatively fast because there was only one hair cell. And then now it's going to ask, because I wanted to, so for say things like the Netrin G1, or like if you want to see the terminals, if you want to have a thumbnail array that includes the terminals, then you also need to make a terminal thumbnail array. And so now that's what it's asking for is, do you also want to do that? And if so, which channels do you want to include? And again, this should be set up good for you. So that's the Cal2 channel right now. But channel 2, I'm pretty sure, is also the TD Tomato channel for the Netrin G1 animals. So click OK. And you might see that it just looks slightly different while this is going. So whenever it's generating the thumbnails, you want to leave the computer totally alone. It is not the most efficient system. And if you go and try to do something else on the computer while that ImageJ code is running, it might end up throwing an error because ImageJ can be a little buggy sometimes. Okay, so it made the thumbnails, but now it hasn't made the array. So it's asking you, do you want to make the array? And you're going to say yes. Proceed with array generation. All right, and sorry, it asks you again. But so now it's going to open up each of those images that it made. It did it. It just happened pretty fast, so we don't see much of it. Do you want to do it again? Yes, do it again. All right, and now it's asking you, okay, I made those arrays. Do you actually want to go and review them because you're going to proceed with counting how many of them are synapses or not? And you say yes. So we're going to review the synaptic array data. Yes. So you do not click this until your annotations are complete. You're going to read through all of this. And what you're going to do is in the background, you're going to go here. You're going to open the analysis file for that image. So this is a new file that the ImageJ code creates. And for every single image, there's one of these files. This file is very similar to, sorry, I shouldn't have had that. Oh, wait, sorry. Okay, that's fine. This file is very similar to the original one that we had created through the Amara stats file conversion, right? So we started with these files, we converted them to these files, and then ImageJ made a new version of that file because we want to keep that raw data raw. And now what we're adding to it is the status, right? So is it a synapse? That's the main thing that we're doing right now. That's the manual part. The pillar modilar status part, that's going to be automatic. So it has all of that previous information, but now it also has new columns. And so what you're doing in this step of the analysis is you're looking at this array and you're determining whether or not these puncta is it a synapse? And so the way that this code works is, you know how I drew a box that said only analyze things in this region? It says if you're analyzing in that region, put a synapse question mark so that you know where to find that. And then there's an ID number here, right? So that's ID number 130. And I'm sorry it's so pixelated, but you can kind of see it. It's much clearer on this image. But so this is a stack, so you should be able to flip back and forth through it, and you're saying, you know, is that an orphan or not? And this one, 130, that's a little borderline. You know, that's pretty faint right there. But 137, that is definitely an orphan, right? Like there's no question, there is no Homer 1 patch right there. So, you know, it's faint, but like I can kind of see a patch there. So I'm going to give it to 130. And you're either just going to tap, right? Like, okay, that one's a synapse. The only one that is an orphan is 137. So hold on, sorry. 137. Okay, so 137. Okay, so this is an orphan. Okay, and then I'm going to save it. So once I enter all those values, I'm going to save it. If one of this was like junk or a doublet or like a custom flag, you can just enter it here and we'll deal with it later. So once that's done, you're going to save it, you're going to close it, come back over to ImageJ and say, okay, I'm done. Now, we are not reviewing terminal arrays right now in this approach, so we're going to skip that part and we're going to say no. All right. So now the last thing that needs to be done is the pillar modular mapping. And yeah, you want to do that. And which channels do you want to include for your pillar modular mapping? You know, I think it's good to have the ribbon marker in there. If you have too many of the channels in there, it might look a little bit crowded. So you might want to test out what combining different channels looks like. But the hair cell marker is channel 2. Is it? I don't know. We're going to see what this says. All right. Don't worry about this. This is just a max projection telling you so that you can draw, like if you only wanted to do, say, 3 hair cells, then you can do just 3 hair cells in that pillar modular mapping. We kind of talked about earlier how you can like break this up into 2 and do 1/2 and 1/2. For now, I would just recommend doing all of them all at once. And if you need to go back and redo it, it's fine. You're not going to really lose a lot of time by doing it. But for now, I think it's just more simple to just do the entire image, and we'll just see how that goes first. The way the code works is it's only going to add synapses that have actually been analyzed, I think. I'm pretty sure. We're going to see. So, all right, so I'm going to click OK. That's for now, we're just doing this whole region, this tiny region, and click OK, blah, 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 does stuff. All right, boom. So now it looks a little fuzzy, but this is the profile view of our hair cells, of those 2 hair cells that I just highlighted. And you can kind of see a pillar modular axis here. I think it included the CALB2. Yeah, it included CALB2 and myosin 7A. And I'm just going to draw, you want to draw your axis across the basolateral region, right? So here's the apical region, here's the hair cell head, here's where the fibers come in. And what you're trying to do is draw a line, draw an orthogonal line. So it's the pillar modular axis is this one that you're drawing, right? So it's going from the pillar side to the modular side, but the angle of the axis needs to be so that the orthogonal line would run along the basal to apical direction. So hopefully that makes more sense after I click OK, but I'm just going to adjust it a little bit to roughly what I think it should look like here. And then I'm going to click OK. And then boom. Sorry, everything disappears really fast because I want to close images to keep memory available. But we can go back and review it in a second. And now finally it's going to ask you like, hey, I went through all the analysis steps. I did everything you want me to do. Do you want to mark this as being completed? And that's just for your own sake so that you know that you finished this image. And I'm actually going to say, no, I don't want to change the status on this because I didn't analyze the entire image. I only analyzed one of the hair cells. So I'm going to just click OK, and then I'm going to exit. And now I can show you what did we get out of that? So the first one is we get a max projection that looks really weird when you just preview it in the operating system, but when you open it here, or no, sorry, this is a Z stack. So this is a full Z stack, but it saved it with the settings that you had. So when you adjusted the brightness contrast, it saved it. The next thing is our analysis folder where it has batch master and it has our CSV for that image. This is what Python needs in order to plot the results. So these are very important files that you want to make sure you back up. Okay, here's the annotated and max projection that has the synapses or the XYZs. Oh yeah, this is just a raw TIFF version without the annotation. Okay, and then here's the pillar modular map. So I think maybe one of these files was left over or, oh, right. Okay, so there's two different versions. One version is with no annotations on it, just so you can see what the raw image looked like. The other is the pillar modular map that includes the synapses. I think that's all of, oh, no, right. So I was right that it only includes the synapses that I analyzed. So if I didn't analyze certain synapses yet, it's not going to be included in the pillar modular map. But then you're going to see, okay, here's the line that I drew. Here's the line that was calculated based on the one that I drew. And then here's all the individual synapses that I analyzed. All right, close that. Summary image. Oh, right. This feature. I haven't finished coding this feature yet. It's not important. So don't worry about that. Here's the synapse arrays if you want to go back and look at them. So they're saved as individual channels, right? So you can say, okay, here's the CTBP2. Here's the postsynaptic one. Those are the terminals. Right, yeah, those are the terminals. Okay, it all saves in one folder. So this is when I made the terminal thing. That's the hair cell marker. Oh, that's the terminal marker. Okay. And then here's the individual thumbnails. So for every image, for whether it was the synaptic array or the terminal array, every single thumbnail has 3 different versions, right? Because there's the pre, the post, and then there's the composite. So that's just for backup, like if you need to go back and review it, and then you already know this folder. All right, so that's it. That's the full process for a single image. The next video is going to be about how to plot those results in Python, but you should be able to get started with your analysis just following here. All right, reach out if there's any questions.